All right. So it's time to start on the Rhino Mill seminar or webinar. So today we're going to go through some 2-axis machining and some 3-axis machining. Now I've imported this part. I'm still not very good with Rhino for drawing. So I've imported this as a IGES file. So I brought it in from a different solid software, and I was able to just convert it to make it a proper solid. And we want to do that. And the way I did it was just by going up here to solid and then create solid, drag a box over all my surfaces when they opened up. And then I was able to just hit enter and it created it as one poly surface. So now I have it set up where it's all showing up as one piece. And this is the easiest way to work with the system because it's allowing the system to detect things around the part. So to get started with any job, we first have to import our model, then figure out what view you want to be in. I like to use the perspective view while I'm doing most of my stuff, but I will be using things like the top view to grab my geometry for my text that's sitting on top because it just makes it easier to drag a box over. So right here, I'll go to perspective, and I'm just going to go over to our CAM tree. Now, if your BobCAM tab is not loaded, if you don't see it right away, just go up into your command line and type the word BobCAM, and that will show your BobCAM Rhino. So it'll show the tab for BobCAM. Now, after the tab for BobCAM loads up, you're going to have this CAM defaults section. And you can right-click on CAM defaults and start a new job. And this is where we define whether we're doing a milling job, whether we're doing a turning job, a mill turn job, or a wire EDM job. So you're just going to choose accordingly for what type of job you want to start. And then down below, based on whichever feature you choose, is going to show the machine. So down below, I'll go to milling. I have all the machines that are loaded in here, and these are all just the milling machines. So I'm just going to use this BC3X mill. It's a generic machine, but it should do the job just fine. And then from here, I'll go right to the stock wizard. Now, when it first loads up, when you go directly into it, the workpiece is a solid model that represents the final finished part. So for me, I could just pick this whole solid here, and then we don't hit OK. If you hit OK, it's going to kick you out of the stock wizard, and you'll just have to re-enter it. We're just going to go ahead and hit next, and it's going to remember that for us. Now we have different stock types. We could choose rectangular stock like we see here. We could go with cylindrical stock and create a cylindrical piece of stock, which is what we're going to end up using. We could also do wireframe stock, and wireframe allows us to select a piece of geometry. So we'll say poly surface boundary there, and then calculate the stock, and then you could define how tall that stock is. Now we also have two other ones, which we can't really use on this one. It's a solid model or an STL file. And both of these kind of work the same way where you're using a model that represents the stock that you're creating. This is really important if you're using casted parts and you just need to go in and remove a little bit of material. That's a really good way to get that done. And then the final one is Revolved Stock, which I really only use if I'm doing mill turn, but it might come in handy at some point on a milling job or 4-axis. So I'm going to go back to cylinder here. I'm going to say bounding cylinder and then calculate the stock. So it creates a piece of stock that's as large as the part that's showing inside the window. After I have the bounding cylinder created, I can go down here to the diameter and the height. And if there's any changes I need to make from there, I can. Otherwise, I'm just going to go and change an offset. So I have my diameter offset, which would be just an offset of the outside diameter, kind of the OD here. And if I said add a 1/2 inch, it's going to blow it up by a 1/2 inch. Now, what you want to realize when you're doing this diameter offset is it's a 1/2 inch total. So right now, the total diameter is going to be 4.5. So that means we added just 1/4 of an inch on either side, and that'll be material we can take down. But I'm not going to add any offsets to it for the diameter. The start face is where we would define looks like my preview for the video is not loading. Give it a second. Can you see my screen right now? Are you able to see the part that I'm working on? For some reason, normally I have a view of what you guys are seeing. Are you unable to see that currently, this part that I got going? If you go to there should be a questions box, and one of you guys could let me know if you see it. For some reason, it's not showing me the view. I do have it showing my screen. People can see your screen. That's good. Let me pause. Let me stop for a second. And then let me show my screen. So here, and show screen. Well, hopefully it's showing you the screen. If not, someone let me know if you could see. You could use the questions box. Just give me a yes or a no if you can see the screen, the part that I'm working on right now. Everything looks like it's set up properly, but it's not showing me my audience view. Usually it does. All right, so I'll just continue on, and hopefully you guys can see what's going on because it's not showing me under my normal view, which is odd, but all right. So after we define the height and the diameter of the stock, we can then define our offsets. So we have our start face and our end face. The start face is the amount above the top of part, so right here. So I could go in and say that's just going to be 100 thousandths extra, and what we'll see is it's going to add that to the top of the part. If we wanted to put some material down at the bottom as something maybe we're holding on to, we could go to, go another 1/4 of an inch or something. And that's what we're going to grab onto. And we can flip this part over and actually deck that bottom side off. We could face it off afterwards. So I'm just going to scroll down here and then hit the next button or the forward button. And this is where we have to define the origin or our work offset. This could be a G54 on your machine. This could be an E1. It all just depends on what your specific controller calls these things. So I'm going to go with the origin. I'm going to go ahead and pick the top dead center point there. And then we'll see my X direction is going to the left. My Y direction is going forward here. And my Z direction is going up. We always want this arrow, the blue one, to be perpendicular to the part, because that's telling BobCAM to go in and cut down. So we shouldn't have any issues here. And then I'm just going to scroll down to the bottom. And I have the Machine Simulation Pro on my system. So what that means for me is when I go into the simulation, I actually see a virtual version of my machine. And so I want to make sure that when we see this virtual version of the machine, it's not, my part is not sitting inside the table. So I'm just going to lift up the part. We'll say 4 inches. And then the clearance plane, this is where we can set the clearance plane. And the clearance plane is used as a safe area for the tool to move around above the part. So 1 inch for me is fine. I'll go ahead and hit OK. And now we have our stock created. So from here, I'm just going to expand the stock first. And then we can see what material is currently chosen. So if we right click on that material, we can go to Edit. And then we could choose any of the materials out of this category. So we have alloy steels, aluminum, carbon steel, cast iron, copper alloy. We have magnesiums, not many. Miscellaneous is where you're going to find your bronzes, your graphites, and nickels. Old cutting conditions are if you're bringing in a part from an old version of BobCAD. It shouldn't be a case of really anything for Rhino because we didn't have Rhino, the BobCAM for Rhino plugin way back then. But just in case. And then we have plastics, stainless steels, super alloys. This is where you're going to find your Inconel and all that fun stuff. Titanium and tool steel. There is no category for wood by default. This is a category that I added in at some point so that I could create feeds and speeds based on wood. So I'm just going to keep it with the 6061 aluminum. So I'm not even going to hit OK on anything. I'm just going to cancel out. And then I'm going to go set up my tools. Now for this job, I am going to have a few tools on here. So we're going to have a center drill. We're going to have a drill. We're going to have a tap. We're going to have a counter bore. And there's a bunch of ways we could do this. So I'm going to right click on Machine Setup 1. No, sorry, we're not going to the machine setup. We're going to the tools. So I'm going to right click on milling tools and we're going to go to the tool crib. All right. Now there's a tool crib and there's a tool library. The tool crib is where we store the tools that we're specifically going to use for this job. The tool library is where all the tools are stored for us to pull into this job. The way I always explain it is think of the tool crib as the shelf or drawer somewhere in your shop that has every tool that you own. Well, you can grab it from there and then load it into the machine. And the tool crib would be the machine itself with all the tools inside of it. So again, the library contains the tools, and then you'll grab however many tools you plan on using for the job and add them to the tool crib. And I just want to be clear, this is not a step that you have to do. You could absolutely start machining right now and go through the job and pick the tools as you're going through them. So it's not that big of a deal. Now I'm going to go ahead and say, let's add from the tool library. And over on the left, we'll see the entire list of tools. So we have all our center drills and all of our end mills and stuff down here. I'm going to start off by just picking my center drill. So I'm going to use a number, we're not going to use a number 5. I'm going to go with a 1/2 inch 90-degree spot drill. And so when we click on it, the first thing you want to do is check the tool out. Before you just add it to the system, look at it. Because if we bring this all the way over to the right, we'll see that this one's made out of carbide. But some of these other tools are made out of high-speed steel. And a lot of the end mills are made out of high-speed steel. So we might need to go in and add the tools or change the tools that are actually needed. So a lot of the tools I'm going to be going into, I'm going to double-click on them, like so. That way I can edit any of the features for this. So right here we have our carbide. And I'm just going to go ahead and hit OK. And that's going to add that 1/2 inch 90-degree spot drill to my job. Now, as far as drilling goes, I don't really need to add a drill or a tap because the system will put that in for me. So now I just need to pick a couple tools for facing. So we're going to go to the end mill rough category. Now, if you click on the category here on the left and then go into the tool library, it'll automatically open you to the correct page, and it'll be the only option you can see. So I'm just going to sort by my diameter. And then I'm going to sort by my diameter again, just by clicking on that. And then I'll go ahead and pick a 1-inch flat end mill standard. So I'll pick that. And then again, if we bring this over to the right, we'll see that this tool in our system is carbide, or sorry, high-speed steel. And I want it to be carbide. So I'm just going to double click on it. Tool material down at the bottom, I'll change that to carbide. And then if there's anything else in here you need to change at this time, this is your chance to do it. So I'll go ahead and hit OK. And there is the tool. So now that I have my 1-inch, we'll use that for our facing. And then we'll add from the tool library once again. This time we're going to sort by the diameter and get us our 1/2 inch tool. So I'm going to go diameter, scroll down. I'll choose the, let's do the 1/2 inch flat end mill. So when we're looking at this, we need to look at the flute length. Right now, we really only have to cut about a 1/2 inch deep with this. So this one here, the standard, has a flute length of 1.125. That one should work. But again, let's go over to the right side. You'll see it's high-speed steel. We'll double-click, change it to carbide, and then hit OK. And that's going to add that next tool into the library, or into the crib from the library. Next, we'll add from the tool library one final time and get our 1/4 inch flat end mill. So I'll go 1/4 inch flat end mill. Again, this one's got a 3/4 of an inch flute length. And so I could either pick that or I can go with the longer one. If I was finishing the outside of this part, it's 1.5 inches total height, then I would definitely use the longer one. But in this case, this 1/4 inch is really only going to go clean up that plus sign or that cross that's in the middle. So we're going to go ahead and choose that tool there. Again, we're going to scroll over to the right, double click on the high-speed steel, and set it to carbide. And once again, when we're done, we'll hit OK. And there it is. Now, we could go put our V tool in here. This would be the tool that we plan on using during our engraving, as well as our chamfer mill. Let's go put the chamfer mill in, and then we'll do the V tool on the fly. because a lot of times you might not have a full plan on what you're wanting to do with your job yet, especially with a V tool. I don't know if I want to go with a 60-degree V tool, if I want to go with a 90 or a 120, something could change. So I'm just going to go and add the chamfer mill. So again, always pick it on the left side here of the tool crib and then hit the add from tool library button because it's going to open up to the correct page. And on this one, I'm just going to go ahead and pick the 1/4 inch chamfer end mill here. And again, this one really depends on the tool. I always say double click on it and get an idea of what it looks like. But then when you hit OK, you'll also get a preview of that exact tool because the picture does not update inside the tool itself. So that is what it's going to look like. From here, we're just going to go ahead and hit OK. And that's going to be our tool crib. Now, after I have that done, I'm just going to blank out the stock just to get it out of my way. I don't really need to look at it anymore. And so now we can get into the tool pathing. The first thing we're going to do is face off this part. So I'm going to right click on my machine setup. And if we go down into here, we have the mill facing feature. It's an automatic facing feature that recognizes the stock. So it knows how large the stock is. And it knows how much stock is sticking above the top of our actual geometry because it's an excess of geometry. So I'm just going to go down to the mill facing, and you don't have to pick geometry. If you do pick geometry, it's a way to get it to avoid areas. But for the most part with facing, I want it to just rough the entire thing out. I want it to clean it up. So we'll see it automatically generates this arc. That's the size of our stock. The top of features at 0 because our origin is at the top of the rough material. And then we're telling it in the system to take off 100 thousandths. So we'll go ahead and hit next again. Right here for the machining strategy, we only have facing with this toolpath, so we'll just go next again. For the posting, no changes there. I want the work offset to match the machine setup that I put together. And then I'll go next again. Right here, it grabbed our 1/4 inch tool, which is fine. It just picked whatever tool it wanted. So we're going to go up here to the tool crib, and we're going to go ahead and choose the 1 inch flat end mill standard, and then hit OK. So now I have this bigger tool to do my facing, and so I'll go next again. Right here for the patterns on a face, you have 3 different patterns that you can follow. Zigzag, zig, and adaptive. So zig and zigzag are very similar. They're just straight lines. It's just dependent on whether that is going to connect when it gets to the end and come back, or if it's going to rapid and retract. So that's your main difference, and it really depends on if you want to cut in one direction all the time, or if you're okay with the tool going back and forth. So I would normally go with a zigzag depending on the material. Now the adaptive function is an adaptive way of cutting where the tool has a constant engagement with the material the entire time. So it's going to keep a constant engagement on the tool all the way around. And so there it is. I'm going to go ahead and run the adaptive. It's one of those ones that it does a pretty good job. I do not recommend having your step over at 50%. If you want to be more aggressive, go to 60%. If you want to be less aggressive, go 40% or lower. But 50% puts that leading edge right on the part we're trying to cut. And sometimes it could lead to some chatter and just it's rougher on the tools. So I'm going to go ahead and say, let's go 40% for the step over. And I'm going to set it to a climb mill. So I'll go next again. Now on the parameters page, the bottom allowance is material that's going to be left on the floor of the part. So if I was trying to leave material because I wanted to come back and face this again at different feeds and speeds, then I'd enter the amount I want to save on the bottom allowance here. Another way of handling this would be on the actual feature page back here where we have it set to 100 thousandths. Have it set to something smaller so you're not taking off as much. But right here, if you wanted to leave it, you could. We have a choice of doing this in single steps, so doing it in one pass, 100 thousandths, one pass, or doing multiple steps. And with multiple steps, you get the choice of doing even depths where we take that value and we divide it evenly, or you could do defined depth. So if I came in and did a depth of cut at 0.03, we'll see that it takes 4 passes to get to 0.1 because you do 0.03, plus 0.03 plus 0.03 gets you to 0.09. And so on the final pass, you'd have just that 10 thousandths, the 0.01 left over. And that's what's going to give you the feature. All right, so I'm going to go with single step there and go next. Now for the leads, I always like to start off the part a little bit further. And so the rule of thumb I follow when I'm doing this is I set my length to half of the tool diameter. And this is usually enough to get us away from the part so that when we plunge to our depth, we're not on the part. We're not plunging into the part. So I'm just going to say the length is 0.5. Next, again, we have our links. So this one doesn't really have any linking options that we have to worry about because it's the adaptive. So really the only thing you're going to run into is if you have a gap in your geometry that's over, in this case, 200% of the tool diameter, then it'll actually wrap it and retract. But for now, I'll just leave that off and go next. And finally, we get to the advanced feed rates. Now, the advanced feed rates are used to convert rapids to feeds. Now, this is common. The reason you'd use this is usually because a machine is dogleg rapiding. So what that means is instead of doing a straight line rapid, your X or Y, just depending on what output, where you're going, one of them kind of moves faster than the other, because when we go into a G00 move, all rapid moves move to their fastest travel, and it becomes non-interpolated motion. And so essentially the G00 is what's causing this. So the convert rapids to feeds here, when you check it, you'll set up a feed rate. And so that feed rate will now output inside the code. But instead of having G00 rapid moves in the code, you'll now have G01 feed moves with the feed rate that you set, because that keeps it in that interpolated motion so it can go in a straight line. There's only a few machines that do that. Not all of them do that. But if you ever see a rapid move above your part that's not going in a straight line and it seems like it's moving on a 45 and then a straight line, that's a sign that you have dogleg rapids. And it might still not be the end of the world. It could be that you just have a, what's the best way to put it? It could mean that you just have really the only time it becomes a problem is if there's something sticking up above the part that the tool could run into. So if you have fixtures above your part, that can definitely cause problems. So we can't hit next anymore. We're not doing anything with the lead in and lead out feed rate percentages. That's a percentage of your cutting feed rate that's just going to be used during lead ins and lead outs. Again, we can't hit next anymore. So we'll go ahead and just hit compute. Now, after I get my first toolpath done, this is the point where I want to make sure I save my part. So I'm just going to go up to File. I'll say Save As. And just make sure it's in my correct folder. And I'm just going to say Save. And that is going to save the toolpath and everything for me so I don't forget. Now that the adaptive rough is done, I'm just going to blank out that feature so I don't see that toolpath. And now we can go and cut the floor on here. So I'm going to start by right-clicking on Machine Setup 1, and I'm going to just go down to the Mill 2 axis here. And the Mill 2 axis allows me to select my geometry, and I'm just going to go in and pick the floor here. Now, the reason I'm able to pick the floor is because of this button right here, this Detect Open Edges. By making sure that my part is a proper solid model and having the Detect Open option or Detect Open Edges option turned on, it should recognize that it can go across the top of those holes and outside the part here. Now, I struggled with this when I was prepping for this whole thing, and it was all because I hadn't done that create solid. You need to make sure that the entire solid is there. If it's just trying to read a surface, it doesn't see the open edges. So you want to make sure everything's, in BobCAD, we'd call it stitched together. In theirs, I believe it's joined mesh or not combined. Yeah, I believe it's a joined mesh. And so that you just want to make sure it's all one. Right down here, we have our profile chains, and these are individual chains for each piece of geometry that's sticking up. But again, these holes that we have in here should be kind of not really seen with the system right now. So all I'm going to do is tell it that I want this start point for this cross in the middle to go right there, and then it'll feed its way down. So that'll be our start point for where we start this cut. Now, when we say pick top, we're just going to go in and pick a point that represents the top of the part. So point or line doesn't really matter. It's just reading that so it now knows that we're going 100 thousandths lower than where the origin is, because that's the material we faced off. For the depth, it is a 1/2 inch, but you can pick it the same way just by picking an edge, and then it'll tell it what the depth is from your top of part. So from your top of feature here down is a 1/2 inch. So I'll go ahead and hit OK, and then go next. Right here for the feature, again, it's a lot of just reiterating the last thing we saw. We do have our clearance plane, our rapid plane, and our feed plane. Remember, the clearance plane is the safe area above everything on your part. The rapid plane is what we would use to say, if we wanted to go from this hole here to this hole here, we would want to use the rapid plane and go 200 thousandths above this cross and then feed over or rapid over to the next hole. Now, the feed plane is used, so if we're at 200 thousandths doing that rapid, we're then going to rapid down to the feed plane. In our case, it's just 100 thousandths above the top of part. So we're going to rapid across, rapid down to the feed plane, and then that's where we start feeding in from. So if you have to ever set your rapid plane a lot higher, you now have a feed plane that's still going to feed in from not so high. So you're not wasting a bunch of time watching your tool slowly feed down to the top of the part. There's our geometry. Now, it looks like a closed shape as of right now, and technically it is. And it really depends on the pattern we pick when we do our profile or when we do our strategy. So when we hit next, we'll see. So if I was to use pocketing, there's 2 patterns we can use. One pattern, and I'll look at them in a second, does not allow us to do open pocketing. It's a standard pattern, doesn't allow open pocketing, but there's another one called advanced pocketing that does allow us to do that open pocket. So I have pocketing, so I'm going to have a pocket and a profile finish. But if we look at this edge right here on the cross, it is chamfered. So what I can also do, because the geometry is the same, is I can use a chamfer mill and move that over. So I'm going to do a pocket, I'm going to do a profile finish to finish that wall, and then I'm going to do a chamfer mill to go in and cut that angle. So I'll go next. For the tabs, there is no tabs on this part. Tabs would be something left on the part so that we have a piece of the geometry or a piece of the part still holding onto the stock so it doesn't fall out. Not something I'm going to do with a part like this, so we'll go next. Right here for the posting, just going to leave it on work offset 1. And that's really it that affects this. This contour ramping output is only available on the profile rough, so we don't have to worry about that. And then right here we have our pocket. So for the first pocket, we're going to go up to the tool crib here, and we're going to choose our 1/2 inch flat end mill, and then hit OK. There it is. We have our tool number down at the bottom, and right now the tool numbering is working based on the order that I've put these tools into the features. So the first tool that was used is the 1 inch. That is the number 1 tool. The second tool that's now being used is going to be the 1/2 inch. The third will be the profile finish, so that will be tool number 3, and we'll see that here in a minute. So there we have our tool number. We have our coolant right down at the bottom of flood, mist, air, or oil. And then right here we have our feeds and speeds. Now the feeds and speeds are modifiable, or you can use BobCAD to figure them out. So what that means is if you want BobCAD to figure them out, you're going to enter in the correct surface footage information, the total feed, your feed per tooth, and your plunge feed per tooth. And you may need to go into your settings under file here and set your decimal places out a little bit further. Now right here we have our spindle RPM, our cutting feed rate, and our plunge feed rate. And what this does for us is the numbers that are going to show up in the code. So if I can't hit 10,000 for my spindle RPM, first thing I would do is go fix that inside the actual machine that I'm using. But if we go in and just type in the values we want to use, we could say I have a 6,000 RPM spindle maximum, and I really don't want to go 138 inches. I'll say we'll go just an even 100, and then I will plunge into it at 25. So we have our cutting feed rate, our plunge feed rate, and our spindle RPM. And if we enter those 3 things, the rest of it doesn't really matter. At this point, I'm creating feeds and speeds for myself. It's not really BobCAD doing anything, even with the material that's chosen. So right there, we'll hit next. Now we get to the patterns page. So I'm going to start by doing a standard pocket, and then we're going to come in and get it to do the open pocket. So I'll do it with an offset pocket out. And we do have an option that if all the cuts that we're making, especially pockets, are circular, you could do a spiral for those circular pockets. Down here we have our climb versus conventional milling. And then right here we have our step over percentage. So this is a percentage of the tool diameter that we're going to use as our step each pass. So for this one, I'll just go with 35% and then go next. Now for the parameters, we have our side allowance and our bottom allowance. The side allowance is what we're leaving all over the wall. So this wall here all the way around, and that's what the finish tool is going to clean up. The bottom allowance would entail us doing another pocket to go in and machine the floor. So bottom allowance is really not something I'm going to use too often. Unless I'm coming back, maybe doing a separate tool with a different set of feeds and speeds, I might use it then. Right here, though, we're going to choose the multiple steps feature, which is going to break that 1/2 inch depth into 2 1/4 inch depths, and then go next. For the leads, we can plunge into the part, we can ramp into the part, or we can spiral into the part. Now, because I'm using the standard pattern, it would be best to use a ramp or a spiral. I'm going to leave it on plunge because I'm not really going to keep the standard option for long. The advanced pocket function is going to allow us to start off the part and then work our way into it. So we're going to plunge off the part and then feed into the material. Next, we have our machine sequencing, and I really don't mess with this too much. My goal is to get through these as quick as possible. I don't want to spend a lot of time figuring this stuff out, and I have no right or wrong way that this could be cut. If it's wrong when I watch the simulation, then I can go fix it. But for now, what I usually do is just turn on optimized because it picks a pretty good form. Actually, the optimized will choose the most efficient from closest, no sorting, and the X or Y direction options. It just doesn't do anything with the custom direction because technically we could set up whatever angle we want right here. So I go with optimized, go next. Right here's the links, just going to go direct. So how do we connect from one pass to the next? And then right here, we have our advanced feed. So again, every tool path you come across will have the convert rapid to feed. And then down here, we have our corner slowdown. So this allows us to, as we work into a corner, slow the tool to a specific feed rate. So if you're getting real jagged corners, you're just not cleaning it up as nicely as you want, this will help you slow down in those corners. And you can define the distance from the corner and then also the look ahead count. And it'll run that way. I'm not going to run anything for the corner slowdown. Next, again, we have our profile finish. So you'll see it grab this 1/2 inch tool. It is tool number 3, but if we go up to the tool crib and we go to the end mill finish, the thing we want to look at is if we bring this all the way over to the right, this auto option. Now, if we go to the tools that we actually picked and bring it all to the right, these say picked. That's because we picked these tools. And that end mill finish that it's giving me, this 1/2 inch one that it's trying to make me choose, is not one that we picked. So what happens is when we replace it, so I'll pick my 1/4 inch flat end mill and hit OK. And again, we'll see it's tool number 3. But that 1/2 inch tool that we saw just a second ago was also tool number 3. Well, now that we've replaced that tool, and because we never picked the tool from the finish category, it's now going to disappear. That tool was just placed there so that basically, it wasn't an empty location. So now we have our 1/4 inch end mill on there. So I'll hit OK. And there it is. Again, I'd come in, set my feeds and speeds, say 6,000. We'll go 75. And again, we could go 25 and then go next. Now for the patterns, we have really only one pattern with a profile finish here, but we do have compensation. So we have system compensation, which means we're automatically compensating the part, compensating the tool for it. And then we have machine compensation. Now, machine compensation gives us that G41 or G42 inside the code so that when we walk out to the machine, if the tool isn't exactly the size we planned for, in my case, if it's a worn out 1/4 inch tool, then we can adjust it at the machine and still end up with a properly cut part. So I like to use a G41, but there is a rule to this that I'll talk about here in 1 minute. Next, we get to the parameters. This is just where we set up the allowance if we were leaving it, which we're not. This is a finished pass, so we don't need any of that. And it's also where we'd set up the depth if we were changing it. But I want to do the full depth. It's only taking off the 0.015, the 15 thousandths that we left on the pocketing routine. Give me 1 second. I got to take a drink break. All right. So again, we're not making any changes here on the profile finish parameters page. So we'll go next. And this is where we get to the leads. Now, all the material should be gone. The only thing we should have remaining is that 15 thousandths worth of material. So I'm not worried about how we plunge into the part or ramp into the part. That would usually only be used if we left some sort of bottom allowance on the job. But right down here, I have my lead in and my lead out. And there's one rule that if we decide to use machine compensation, we cannot use a vertical lead in, because it's during the actual lead-in move on at the machine that the machine will kick that new compensation into gear, we'll say. So I'm going to go with just a circular lead-in. And the rule of thumb I follow is, for really any leads, it's a good rule of thumb. It might not be always the case, but it's a good rule of thumb, is use half the tool diameter minimum. So if I was using a 1/4 inch tool, the smallest I would want to go would be 1/8 of an inch. But honestly, we should be fine with a 1/4 inch. We got plenty of space out here to do that lead in. All this material should be gone. And so we'll try it that way. For the corner types, I'm not making any changes to that really ever. The machine sequencing, I'm going to choose optimized. And then the advanced feeds. Again, corner slowdown, the convert rapids, and the lead in, lead out feed rate percentages. Right here we get to our chamfer mill. There's that 1/4 inch chamfer end mill that I set up earlier. So I'll just go next. Or before I go next, I'll pretend my machine can only go 6,000 for all these. So I'll go 6,000 RPM, say 35 inches a minute. Again, plunging 25, that's fine. Now right here for the patterns, we're going to use a compensation just in case I need to make a change. So this is essentially a profile finish toolpath. It's almost the exact same toolpath we went through, except for this page here, the parameters. So the cutter position is the offset amount so that we're not using the tip of the chamfer tool. This is a flat bottom chamfer tool, so I don't want to start right on that edge, right on the bottom edge there. So this is going to shift us over so that we're using more of the side of the tool to do the cutting. The small diameter, the chamfer angle, and then this option, whether it's a sharp or a flat bottom, all of that information is getting read from the tool that we picked. So we have this 1/4 inch diameter, 1/4 inch wide, but it has an 1/8 inch flat on it, and it's a 45-degree chamfer. Now, the other big thing about chamfering, it does not use the standard depth amount. It uses, you get to pick a new depth for this one. So you could choose either the depth of the chamfer, the length of the chamfer, or the width of the chamfer. But the chamfer depth is the only one that you can go pick. So these ones, you'd have to define the length. This one, you'd have to define the width. And so I like to use the chamfer depth because I could say pick bottom. And then I can just pick the bottom edge of the chamfer. It doesn't really matter which one you pick. Just click on one. It picks the end point. We can see it just barely got it right there, but we'll hit OK, and we'll see that it's now going deep by 20 thousandths. This is making a 20 thou chamfer around. And so we'll go ahead and hit next. Right here's our lead. So again, I'll go with a circular lead. Use my 1/4 inch for that. Corner types, no changes. Machine sequencing, optimized, and no changes for the advanced feeds. Like I said, that chamfer mill and even the corner rounding, they're basically profile finishes with different tool types. So now we'll go ahead and hit compute, and we'll see there is our tool path. But right now we'll see that the pocket itself, let's go ahead and blank this out. The pocket itself really isn't doing much. It's only going in, kind of cutting a couple little areas. The profile finish is doing a lot. And then the chamfer mill's there. So this is a standard pocket. And essentially it sees this outer wall as a wall that we're not allowed to violate. It's a wall. So I'm going to right click on the pocket and say edit. And I'm going to go next one time to the patterns page. And now we can look at the advanced pocket. Now the advanced pocket actually has the same options as the standard pocket. The standard pocket is parallel, offset pocket out, and offset pocket in. Well, the advanced pocket also has a parallel, an offset pocket out, and an offset pocket in. So it works out really nicely. Right here, I'm going to go with the offset pocket out, but we do have one called Morph Spiral. And what this is going to do is it's going to get rid of any of the linking moves that we normally see. These moves where we link together, it's going to kind of just set everything on a slight angle so they naturally lead into each other. And we also have the adaptive roughing, which is the high-speed machining strategy. I'm not going to do that. I'm just going to go with the offset pocket out, and I'll leave my step over there at, well, put that down to 25%. There's not that much material around here. And so since we made that change, we should be able to hit compute. It'll take a little bit longer to calculate this time around, but we now have a toolpath that goes all around the part. So there's the pocket, there's the profile finish, and there is the chamfer mill. Easy peasy. Now we can go in, and there's a bunch of different ways to handle this next one, but we could go in and either do a mill tap hole and drill and tap our hole and then add our counterbore to it. Or in our case, if we're using a counterbore drill, we could just go right here to the counterbore tap hole option, and we'll go and select our geometry. And I'm just going to go in and pick the wall, the floor, which is the surface right there. We'll grab that surface, and I'll grab the floor in between. So we'll grab all three of them, and I just want to do that on all of these holes. So that one, and that one. We'll grab that one. We'll grab that, and that. I grabbed some point. There we go. We'll grab that, and then we'll grab that one. And this one's going to be, oh, I got both of them this time, so I'll go that one. Oh, I deselected it. That surface, and then I need that floor. There we go. So there it is. So now I have all four chosen, and I'm just going to go ahead and hit OK. And then we'll see the hole diameter is a little bit big. The depth is a little off. We'll go in and pick this stuff because the counterbore, the hole diameter should be, let's see, we'll find out. Yeah, there it is. Hole diameter is a 201. The depth is 3/4 of an inch. The counterbore diameter is 0.75, and the depth is 1/4 of an inch. So something's off here in some way. I believe it's this one. We'll find out when we run it. But I'm going to go ahead and say that my thread type down here, so I'll say thread type, this is actually going to be a course thread, so UNC, and it's going to be a 1/4-20. Where are you? There it is. 1/4-20 is what I set this up for. Now, the only tool we really set up when we did this was the center drill. So I'm not too worried about it because the rest of the tools that BobCAD picks are going to be set up for tapping. So it's going to pick a 201 drill for the 1/4-20 tap, and it's going to pick my 1/4-20 tap itself. So we'll hit OK, and then we'll go ahead and hit next. Right here we have our sequencing. So right now it's on this hole that's a 1/2 inch, so I don't know which one it's trying to drill right now, or if we have something. We're going to look at it when it's all done. And so for now, I'm just going to hit next. Right here for the strategy, I do not want to do a chamfer drill. I will use a counterbore drill, but we also have the ability to do a counterbore mill, which is what we'll try and use on the next one. Right here, we have our machine sequencing. Just going to leave that on optimized. Right here for posting, no changes at all. And one of these might not work. I have to look at the geometry when we get down to the next one. For the center drill, we got our 1/2 inch 90-degree spot drill. And so it allows us to define either the depth we want to go with that spot drill or the center diameter we want to be at when we get to that spot. So I'm going to say that I want it to be at 0.18, and we'll see it's just going to send us to a depth of 0.09. And then we can choose to peck or single depth that. For the drill, it's got this 213 drill, which I'm not going to mess with that. I think this is doing all the wrong holes. We'll find out. Right here's our parameters. I'm just going to get down to where we have the corrected one. So this one here should be the one we want. So the top of feature, the total depth, and the counterbore right there. We'll go next. For the strategy, going to just get rid of that chamfer drill. and just kind of work my way through here. Again, we have our center drill. This one we'll see is a 201 drill. We'll see the counterbore drill is 3/4 of an inch. The total depth is 1/4 of an inch. Now this is getting added on based on the counterbore right here. So we can see that the small diameter is that diameter there. I'm going to set that to 0. And then the small diameter length, how much is actually sticking out, is also going to go to 0. So this is as if I'm using just a 3/4 inch end mill. And I'm just going to set that to we'll say a 1/2 inch flute length. There we go. And I'm going to say, yes, I do want to make those changes for every other feature that uses it. And that way we'll see that it's kind of like just doing a flat bottom drill. It's going to go in and cut to 1/4 of an inch. We could peck. And then right here we have our 1/4-20 tap and our parameters. So we're going to go ahead and just hit compute. And we're going to see what that gives us. So I want to blank these out and see each individual piece. So we have a center drill that runs around the part. We have a drill that runs around the part. We have our counterbore drill and then our tap. Now, is that tap going all the way through? It is not. So it's not really helping us there. So that was probably just an excess piece of geometry. I might have grabbed one of the points for that, but it looks like it got everything right. It's reading that one. So we'll find out. Then we have our other ones, which are the two of these. So we have our center drill. We have our drill, and again, that one is going through. We have our counterbore drill, which should be just going down to the 1/4 of an inch depth there. And then we have our tap, which once again is going through. So I'm going to delete this whole pattern that it made. I'm just going to delete that whole thing just by right-clicking on it and saying delete, and then yes. And then we're going to look at this, and I want to see if this looks right, because it seems like the tool is going to be too big. These should be 1/2 inch holes. So let's back plot this counterbore drill here, and we'll see it is way too big. It picked the wrong hole size. I don't know. I must have picked the random point in there or something, so it picked the wrong tool. So we're just going to go edit this. I'm going to go up to the tool crib here, and I'm going to add from the tool library. And this one's going to be a 1/2 inch cap screw counterbore, we'll say. So we'll pick that. And then I'll hit OK. And then I am going to change this one. So again, the small diameter. It's not I want the diameter. I'm just going to make my own. So it's a 1/2 inch diameter. There is no small diameter for either thing. And this would be as if I'm using a 1/2 inch end mill or a counterbore drill right there, 1/4 inch deep, compute. And so now if we watch it and we back plot this guy, that should be what we're looking for right there. So it's just going to that 1/4 inch deep and then leaving. So that looks a lot better. Now, the other thing we'll notice when we look at all these tool paths is where it's linking. Right now, and you can see it in all of this, it's linking through the part. So the first thing I want to do is edit our feature. And I'm just going to pick my top of feature. So I'm going to say pick top, and I'm just going to pick it as this top edge of this arc right here, or this edge over here. Let me pick anything. That point will work, actually. So we'll hit OK. And so we'll see that that one's minus 0.6 because we had the 100 thousandths on the top of the part. So we took that down, and then we're down another 1/2 inch to get to this floor. The feature depth is 3/4 of an inch. That should be fine. But if you weren't sure, you could say pick bottom and just pick the bottom edge of the part right here. Any part that represents it. So just right there, hit OK. And we'll see that that now is going to go 1 inch deep. So that's enough to make sure we clear all the way through. All the other values should be updating. I'll set the counterbore diameter to a 1/2 inch. And then the diameter for everything else is matching for the 1/4-20. So the only other change we need to make is if we look at this right now, all these holes are grouped together. So it's only going to use the clearance plane up here or the rapid plane to connect us together. Right now it's using the rapid plane, but the rapid plane is 0.2 above the cut we're making, which we're currently at minus 0.6. So we're only going to go up to minus 0.4 and then try and cut through the part. So what we can do is either set that rapid plane higher, set it to 0.6 plus the 0.2. So you'd have a 0.8 total. That would get you over the top. Or we can break our hole group. And what that does is it breaks it into 4 separate 4 separate holes. And after you break into 4 separate holes, when we go from one to the next, it's going to use the group retracts. So it's going to use the clearance plane. This is where it's pulling that number from. So for this one, I'll just set it to 200 thousandths, hit OK, and then recompute. And then once again, we'll go ahead, whoops, wrong way. Once again, we'll go ahead and look at this, and we'll see we have our center drill there. Now we're going over the top of the part. We have our drill, our counterbore drill, and our tap. So that looks pretty good. All right, the last thing we have to do for this part before we simulate it and post it is the BobCAD text that's right here. So for this one, I'm going to just right-click on Machine Setup 1. And now we could go in and use a Mill 2 axis to do this. The problem that we run into by using the 2-axis engrave is that you're limited to 1 depth. You cannot do multiple depths. So if I wanted to say, take this to, we'll go to 50 thousandths deep, but I want to do that in 2 passes because I'm using a little V tool, I would have to make 1 2-axis engrave that goes to 25 thousandths and another 2-axis engrave that goes to 50 thousandths. So it's not something I use very often. The engrave that I use is down at the bottom here where it's called the Mill 3-axis wireframe. And this is actually a 3D engraving toolpath, but it's only a 3D engraving toolpath if the geometry you're selecting is 3D geometry. If it has curvature to it, then it is 3D. But in my case, I'm just going to say select geometry. This geometry is flat. I'm going to go to my top view, and I'm just going to drag a box over all of the text. So let me try that again. Should let me pick the text here. No, none. Don't pick anything. Let me get out of that. There we go. So I'll pick. I just want the text though. Oh, hold on. Let me turn this to a wireframe. There. None. Yeah, I want the curve. But I want all the curves. There we go. I got it now. All right. So I needed to get in there to drag a box. And there we go. It now picked all of the text for me with nothing else. So you'll see just curves on here. If you see any sort of surface edge or anything like that, then we would want to delete that or find out where we went wrong. But that just grabbed all those curves for me. It is all broken. I didn't re-poly group it. I didn't set it back up that way. And so right here we have our start points. That's where we're starting on everything. And my main focus for these ones, this is a center line cutting toolpath. So it's whatever direction you want to cut in, you know, climb or conventional, kind of doesn't really matter that much on here. Now the top of job right now is currently set at 0. So if I go back to my perspective view and I was to pick the top, just any edge, we'll see it's actually minus 100 thousandths because again, we faced off that much. So now we'll hit OK, go next. Right here, we have our feature page, so it's got the correct top of feature. This is technically a 3-axis toolpath, so it doesn't give you a preview of the geometry. Right here's the machining strategy. So I have a 3-axis engrave, which is a rough. We do also have a finish pass, so I'll go ahead and add that in. The finish doesn't actually have any parameters. It's just a chasing pass that's going to go through and cut, you know, just clean up the cut again. Work offset 1. Right here we have our 1/4 inch tool. It doesn't automatically go for a V tool, so we go up to the tool crib, and then over here on the left we'll see all the supported tool types for this. So I'll go to V tool and then add from tool library. This is the one we're doing on the fly here, so I'll pick I'll use my we'll go with an 1/8 inch 60 degree, so it should have a nice tip to it, should keep a pretty thin letter, and so we'll hit OK. And there is the preview for it right there. So that's going to be the V that we use. And then we'll go next. Now for the parameters, when we go to set our depth of cut, with the 2-axis that we've looked at already, like the pocket, we have a defined depth that we want to go, which in our case earlier was 1/2 inch. So we went 1/2 inch deep. And when we got to the parameters page, it was asking us how many passes we wanted to take to cut that 1/2 inch in. And so with the parameters on this one, it works a little bit differently. If I was to say I want to go with a total distance of 50 thousandths, right now it's going to do 50 thousandths in 1 pass. If I said, let's do it in 2 passes, this does not mean I'm going to do 50 thousandths in 2 passes. It means I'm going to do 2 passes at 50 thousandths per pass. So I'm going to end up going 100 thousandths deep. So for this one, you always multiply these two numbers together. And the way I actually figure it out for the most part is I take my total distance I want to go, and then in here I'm going to divide it by the total number of passes. And it's going to work out to 25 thousandths. 2 times gets me to 50 thousandths total. Now right here you have your direction options, and there's 2 of them. The cut from geometry means that the geometry, the text, the whatever, the wireframe, the curves are sitting on top of your part. You're cutting from them down into your part. So you're cutting from the top of the part down. The cut to geometry is usually how parts show up when an engineer is going to draw them and put them all together for you, where they might sync the text into the part file. The cut to geometry is going to say you pick the text at the depth that the text is drawn, and then you define how much to cut to that geometry. So for this one, we'll go with the cut from geometry and then go next. And then finally, this is just a cleanup pass. So we're just going to go tool crib. I'm going to go over to my V tool. I'm going to pick that 1/8 inch V tool once again. And then we'll hit compute. And there is the text. So if we go and turn our part to wireframe, we could see the 2 passes inside of there. Looks pretty good. So we'll go back to our shaded. And then finally, that gets us to the end of all the tool pathing. But it's finally time to go check out the simulation and see if we did anything wrong and see if there's anything we need to change. There's a lot of settings I didn't change because we don't have to. The defaults are good enough. So I'm just going to go ahead and launch the simulation. You can do that right at the top of the CAM tree, just above the CAM defaults. Right there, we have simulate the toolpath for the selected job. So we're going to go ahead and do that. And while that's loading up, I will be right back. All right. So now that it loads up, the simulation loads up, we'll go ahead and say run. And it's not too fast. So there we go. We'll do that in 1 pass. And then we got our 1/4 inch passes. And this is that advanced pocket. So it's going to shave as much of it out as it can until it can do a full pass. So now we'll see it start moving around the part right there because it can now squeeze all the way around, do the couple passes we need right there. Just let it keep going. And then soon we're going to see it switch tools to the profile finish. So the 1/4 inch tool, which is the radius we need in those corners there. And then our chamfer goes up top, just like that. And then we're going to go center drill. We're going to drill. We're going to counterbore drill. And we're going to go and tap all those. And then finally the V tool is going to come in. 2 passes for each letter. And there we go. This is just a chase pass. Again, the finish pass is really just going in and following the geometry. A lot of times if I was going to do it, I don't actually put a finish pass. I would just rerun operation number 9 again and let it clean it up. So now that it looks good on there, the last thing we have to do is we want to flip this part over, and I want to take off the other side of material, the 1/4 inch that we left on the other side. So to do that, I'm going to first just blank out that feature that we have. I like to blank things out and then shrink them up using the arrows when I know I'm done with them. And then I'm going to right click on the milling job. And I'm going to say add setup. Now machine setup 2 is going to pop up, and I'm going to right click on that and say edit, which is going to load up the last page of the stock wizard. And we'll see all those points that we used to originally pick our origin. So I'm now going to flip this part over, and you do want to make sure you flip it the right way so that when you set this up, your X and Y are the correct direction. But really, this is just going to be a face pass, so I can flip the part over and deck off the bottom 1/4 inch of it. So I'll say origin, and I'm going to pick that point right there. Now, what we want to focus on when we're trying to get this set up right is that blue arrow needs to face we want it pointing away from this surface. But I tell people not to focus on that Z being wrong. Try and get your X and your Y set up correctly, because that will set up the Z correctly because we follow the right-hand rule. So I'm just going to go ahead and flip my X-axis using this little button here. And we'll see now we have our X-axis going this way, our Y is going that way, and our Z is going up. So once again, I'm just going to add a Z of 4 inches for my simulation, hit OK, and now I can right-click and do my mill facing. Or I can copy my mill facing that I've already done and paste it under machine setup 2. So I'll just paste that feature, and I'm just going to right-click and compute the toolpath. And it will automatically recognize the 1/4 inch depth that we had to take off. So if we go to our feature page, it knows to take off that 1/4 inch. It knows what tool to use. It knows what pattern to use. The only thing I'm going to change is I'm going to do multiple steps, we'll say, just so we do it in 2 passes. We'll compute. There it is. And now finally, if we simulate this part once again, it should be the entire part to size. So once again, we'll say run. And we're just going to let it face off the top. We'll speed this up a bit so it can run through the whole thing. And then we do want to slow it down. There we go. Now we get into the bottom side. It automatically flipped it. And now we will be facing off that bit of material there. So there is our first pass, and now our second. So if we want to compare this to kind of the part we just made, we want to see how we machine this versus what was drawn, you can go right here to visibility and turn on your workpiece. And your workpiece is going to show a copy of the solid model that's underneath it. So things might not show properly. Like we'll see right here that the holes that were originally drawn are drawn to 201. That's the drill that we're going to use. But we tapped them to 1/4 inch. So they are going to be a little bit bigger. That would be the major thread size there. That's what we're seeing there. As well as the text that was cut in. I didn't have that sunken into the part at all. So it's just showing a flat surface. But if we turn that model off, we can see the V-tool look good. The other thing to look at, though, is the sides of it, the walls. And we'll notice that there's both that blue color and the white color. And that basically comes down to the fact that the simulation is showing us 2 surfaces that are sitting flush with each other, sitting perfectly with each other. So it doesn't know really whether to show you the blue machined geometry or the white workpiece geometry. So that's a good sign. That's how we want our parts to come out finished. There's some other ways of checking inside the simulation if you're all to size. But for now, we're going to close down, get out of the simulation. Now would be time to generate a setup sheet and post the code. So I'll post the code first. Before we post any code, we always want to ensure that we have the correct post processor, which can be found right under the machine. And I'm just going to right click on milling job here and say post. And the code is going to show up right here on the posting tab. And there it is. So from here, I'd right click and either save it, or I would bring it to the NC editor and I would let the NC editor, I would take it there and edit it some more. And then finally, the last bit for really any job that I do, and really before posting, I guess there's two little bits, is the machining order. So if we right click on milling job, we can go to machining order and we can see how it's currently sorted. Now, we don't have really any tools that are repeating themselves, so there is no kind of right or wrong way of doing it. But just so you know, individual feature is going to run the feature in the exact order that you've set up your CAM tree. Individual tool or individual tool per machine setup will group the tool together. That's really used more often when you don't have a tool changer, because you want to do as much as you can with one tool before having to switch. But again, since we don't really have any repetition going here, it's not really going to matter. But if we set individual tool and we hit OK, we will see that machine setup 1 and 2 is now at the top. So it's going to try and face off the top of the part. And then the way this is running now is the part would flip over, we'd face off the bottom, and then we'd go back to op 1. So individual tool groups the tool together regardless of their machine setup. Because machine setup 2 could technically be, instead of a part getting flipped over, we could set that up to be a vise, and we could have it in a different location. So you could face off the top of one part in the vise, and then with G54, and then with G55 go to a completely different vise, face it off. Maybe you're doing a whole bunch of these parts, so you got one set up as a rough piece of stock, you've machined it, then you take it, you flip it into the other vise, you reload the first, and then while you're running another op number 1, you're also jumping over to finish out that op number 2 on the other part. So there is a reason we have it like this, but if you're only using, in my case, I'm only using one work offset and I'm flipping my part over, we would definitely want to go with individual tool per machine setup or individual feature, which we shouldn't see any difference now because, again, there's no really repetitious tools that we got going on. So when we're done, we'll hit OK. And then finally, we'll generate our setup sheets. So we'll right click here and say generate setup sheet. We have our full setup sheet, and that's the one I always use. I'm really not going to change it, so I'll hit OK, and we can run it. Now, if the tool numbers show up incorrectly, there is an option for that as well. So we'll see here's all the breakdown of everything. We got the tool list, we got the stock information, the total cycle time for the whole job at the feeds and speeds we're using. So it's calculating the feeds and speeds. It's got the name of the file, the date, the time, the machine, the post, everything we'd want to know. Again, there's all the tools. Right here we have our cycle times here, as well as speeds and feeds calculations, which operation it's on, overall just all the information we'd want to know about the job. Now to save this, I would right click and then go down here to print. And if you have Windows 10, and I assume Windows 11, I haven't seen it yet. If we have Windows 10, we can print it. There we go. And I can print it to the Microsoft Print to PDF here. And what it'll do is when I say print, and I'll make sure we're in the right folder, it's going to pop up a dialog box for me to save. So I'm going to go here and I'll say part 1 setup sheet. And then just say save. And now I can come back to that page whenever I need it. I can just add it in. I could print it out again, or I could just open it up for reference. So now that it's saved, I could close out. And the last thing, the tool numbering, you can find by right-clicking on the milling tools here, and then down to the verify tool assignment. Now, the verify tool assignment's a little bit different than your tool crib, because the tool crib, you could technically have a tool crib that has 20 tools in it, but you might not be using all those tools. So what this allows me to do is see the tools that are actually being used on this job. And so if I go down here and I uncheck where it says use automatic tool numbering, I can double click on each tool number and change them to whatever I want. And if I was to just hit OK now and post my code again, we'll see the tool list. I guess this post doesn't have a tool list, but we'll see now that instead of being tool number 1, it's tool 256. If we keep scrolling down, we'll see this one is now tool 89. And so it changes it. But again, if I go back into there and turn on the verify tool assignment, use automatic tool numbering, and I'll repost my code, we'll see we are back to tool number 1, tool number 2, right there. And then I don't know how long tool number 2 is running for. That's the whole open pocket. So there's a lot of geometry happening for that. Yep, there we go. And then there's tool number 3 right there. So there it is. If you have any questions, go ahead and put it inside the questions box at this point. You can ask questions whenever. I'll try and answer whatever you got. This is going to be a short one. We're going to end before lunch today or at lunch. Instead of doing this for another 2 hours after, we're just going to do the 2 hours here. There's not many of you guys. I had a few more signups, but they didn't show up. So, and we're going to get through it all. So that's my 2-axis part. So I'll go in and just say save. So it saves it. And I'm just going to open up my 3-axis part, which if you've seen the, I don't want let me go up here. If you've seen the BobCAD standalone version, this is one of the parts that's built into the system, and it's a really nice part for just kind of getting an idea of what you can do with the 3-axis. So we'll give it a second to load here. And there is the part. So I'm just going to change this to a gray color here. That's all right. I can deal with that. So once again, the first thing I did when I brought this in, because again, I brought it in as a, as a IGES file. And then I went to my solid and I did the create solid. So this one's also lined up with my XY axis where the corner is going to be my origin, but that's where it's lined up. Excuse me. So now we're going to go over to our CAM tree. We're going to right click on CAM defaults and say new job. And we're going to choose that milling with the BC3X mill. And I'm going to go right into the stock wizard here. So once again, the stock wizard, I'm going to pick my work piece first. So I'll pick that part and then go next. And then it creates a rectangular piece of stock. So we'll wait for it to load. It's just got to catch up to everything. Or I might need to restart my Rhino. It has been a little while. So yeah, we'll let that run. Yep, there it was. So I should have restarted, and I really should let me get rid of some of this stuff here. I don't need that anymore. I don't need any of this. All that can go. I got a bunch of stuff running right now, so I don't need GWizard up anymore. Give me 1 minute. That's the webinar. That's our tutorial section, so that can go. All right, so cancel that. That. All right, so I just need BobCAD to close down now, which I should be able to just kill from this. All right, so Task Manager took care of that. And so let me just open up my Rhino once again, and we'll just wait for it to load. We'll restart. We weren't too far into it. Don't know why the stock was why it locked up. Worked earlier, but might be the fact that I've had Rhino running since yesterday to prep for this, so I didn't restart it this morning. So that was probably my mistake. It's how it usually goes. So I'll open this up. Oh, and there's an update available. All right, so we'll open it up right there. And then I should be able to, I'll just wait for it to load. I got to move it over to my other screen here. All right, we'll move that there. And we'll do that one. All right, there we go. So it's back. So we'll give this a try again. Let me just edit the color once again. And we'll go with a lighter gray this time. A little bit lighter. There we go. Let's go a little bit lighter than that even. There we go. I can deal with that. So now we'll go into our CAM defaults. We'll try this again. See why it got stuck last time. We will pick our workpiece, which looks good. and then we'll say next, and it should take us to the stock quiz. That's what it should have done. There we go. It's got a rectangular piece of stock, 6.5 by 4.5 by 2 inches tall, and that's what I square up the block to before I started. Right here, we then have our origin, which it automatically picks the corner of the XYZ plane here in Rhino. So this part's oriented right there automatically. So there's nothing I have to change. The only thing I'm going to do is lift it up in Z 3 inches. Then I'll hit OK. And then again, I'll blank out that stock so we don't have to look at it. So there is our part. I'm going to change that color one more time. I want to do something a little bit crazier with some blue, but nothing too dark. Something like that, just so we can see it. There we go. I can deal with that. So now we can start our machining process. Now, I'm not going to worry about facing this off. Again, this would be a block of material that I've already gotten set up and squared away for this job. So other than the drilled holes, this is primarily going to be done with one single wizard of toolpaths. It's going to be multiple toolpaths still, but it's only going to be one wizard. So I'm going to right click on my machine setup one, and I'm going to go down to the mill 3 axis. And I'm going to select the geometry. Now, anytime we are doing a 3-axis job, the easiest way to do it is say select solid body, pick the full solid, and use that. Now, I'm going to be using the Pro toolpaths for this, so there is no boundary that's really needed. If I was to pick a boundary, I would use probably the bottom edge. So I'd use this bottom rectangle here and pick that surface, and it would essentially lock it into there. But realistically, if I was to use the standard toolpaths, I would want to offset this out. I'd want to make a box that's a little bit bigger than that, because that way I'm not limiting myself on the tool having to stop when it gets to the edge. But if I use the Pro toolpaths, they will recognize where the stock is, and they'll go out of their way to make sure they machine it. Top of features at 0 because our origin's right there, and then we'll go ahead and hit OK. Next, we then get to our feature page, so nothing to really change here. And for the machining strategy. So again, if you wanted to do this with the standard toolpaths, your combination would probably be a Z-level rough, a Z-level finish, and a planer, but that's not going to be able to finish everything, and that's why I want to use the pros. So the pros start down here with the advanced rough. So I'm going to do an advanced rough. I'm going to do an advanced well, actually, I'm going to do a second advanced rough. So the first advanced rough is going to use a large tool. We'll use a 3/4 inch tool on that one. The second one is going to switch to a 1/2 inch flat. The next tool path will be an advanced Z-level finish using a 1/2 inch ball mill. We'll then use an advanced planer with a 1/2 inch ball. And then finally, we're going to add in a pencil mill, which is going to use a 3/8 ball, which is the size of the radiuses for all these corners. So we'll go ahead and hit next. Right here for posting, if you're getting into 3-axis, if you go to post your code and you don't see any arc moves throughout, it's usually this little button right here. If you don't turn that on, you won't get any arc moves out of your program into your code. So this just kind of enables arcs in the program. So we'll go next. Right here for the roughing tool, I'm just going to define these ones by hand. So I'm just going to uncheck the system tool or leave it checked and then change my tool to a 3/4 inch flat end mill. And then you'll see it will update automatically to that 3/4 inch end mill. The only thing we'd want to do is make sure we have enough length on there. So I'm going to say that the tool sticks out 2.5 inches, just like that. We have our tool number, feeds and speeds. Right here for the patterns. Now this is the advanced rough. So it's a very smart tool path. It's a very powerful tool path. And so right here we have our offset in, our offset out. So offset from the inside out or outside in, morph spiral, parallel, or we could do the adaptive roughing or high-speed machining. I'm just going to go with the offset out, keep it real simple. We're going to do a zig pattern so the tool keeps moving in one direction the whole time instead of reversing directions when it gets to different end and start points. And I'm going to make sure to climb mill. Next, I then have my parameters. So for my depth of cut, this is really whatever you're comfortable with the tool taking out. I'm going to go with a 3/8, so 0.375. And my step over, I'll set it to just an even 300. So we have less than 50% for the step over and about a 50% depth of cut on here. The problem is we're going to leave big steps on the part if we run it with this big of depth of cuts and step overs. So a way that we can fix that is by using intermediate steps. And we can just check that button on and then say number of intermediate steps. So how many times when I finish roughing this, it's going to have steps all over the part. And this intermediate steps is essentially going back and recutting just the steps so you can get a smoother finish before your finish tools start coming in. So go with 2 intermediate steps. No changes for the detect stock thicker than. And then right here we have our machining tolerance. So the machining tolerance is essentially the allowable deviation. It's the amount of change that's allowed to happen as the toolpath runs. So if we're running a straight line, this tool's allowed to move within a 0.005 of that line. So back and forth a 0.5 thou. And so it's a real small value. A lot of machines can't even hold that kind of tolerance. So this is a pretty good place to be. The toolpath will be created with a nice, clean, good tolerance. If you go lower than this, so if you go down to, say, a 1/10, this will take longer to calculate. If you were to go to something like 5 thou, this will calculate faster, but it'll give you a worse toolpath. Going down to that 1/10 would give you a better toolpath, but it will take longer to calculate. So I usually use the 0.5 thou. With newer computers, more recent computers, they calculate pretty quickly. It's usually nothing too bad. So we'll run that. Right here we have ignore holes or cut holes. I'm going to say ignore holes, and it shouldn't go in and try and machine any of those holes. For the depth options on this advanced rough, I pretty much always use a min-max from both. That way it's looking at the machining surfaces and the stock, and it's going to kind of recognize where there's stock and where there's not, and it's going to go and machine. Now the allowance XYZ, we're at 15 thousandths. So we'll just leave that much across the entire part. That's a global allowance. So every surface, every wall, every floor is going to get 15 thousandths left on it, minimum. There might be a little bit more in some areas. And then right here for the allowance, we also have a choice of doing side and bottom allowance, kind of like we do with the 2-axis. Because right now I am using a 3/4 inch flat end mill. If I had a lot of big flat areas on this part, I might want that tool to go in and finish those areas for me. So I'll go with global and then go next. For the leads, we can plunge into the part or we can ramp into the part. And with this advanced rough, we can ramp with either a line, a spiral, a zigzag, or a profile. Now, because we didn't give this a boundary and because it's got open sides, it's got 4 open sides, it will usually start off the part and work its way in. But if you go with automatic, BobCAD is going to choose the most efficient option from either the line, the spiral, the zigzag, or the profile. So I'm just going to go with plunge because, again, we should be plunging off the part for this, and then I'll go next. Now, for the options, this first initial advanced rough, there's nothing special about it. We're not doing anything crazy. So on the options page, the only thing I'm going to do is say machine flatlands. And what machine flatlands is going to do is it's going to recognize any floors that happen to fall in between our depth of cut, which right now we're at 0.375. So not too huge, but if there was a floor that was 1/4 inch down, so 0.25 down, and we're going with a 0.375 depth of cut, it's going to ignore that 1/4 inch floor because it's not at the level of our cut. So machine flatlands, it's really not going to do anything on this part. I don't anticipate it to really clean up much, but it's not going to hurt anything either. So I'll go next. For the links, we can go direct. We can make an S-link, which is a tangent lead out and a tangent lead back in, or we can do a full retract. Next, again, we have our gouge checking. No changes there because I'm not, at this point, I don't know if there's going to be any gouges. I assume there's no gouges until I see one in the simulation. So we'll go next. For the advanced feeds, we have convert rapids, we have that link feed rate, and then we have some adaptive feed rates, which if we were to use the adaptive roughing, you will get volume-based, where you could speed up and slow down based on the amount of tool engagement or volume you're encountering, or radial chip thinning, essentially letting BobCAD speed up and slow down so that we get the right size chip off the part every time. So I'm going to go with the offset out. And then right there, that's fine. Now for the second advanced rough, I'm just going to use a 1/2 inch flat end mill. And so this is going to be sticking out, we'll say 2.5 inches. And there it is. Now I'm going to treat this one the exact same. The only difference is I'll leave my depth of cut and step over. We'll just leave it at 100 thousandths. But again, we're using that 15 thousandths to save the material. The leads, that's fine. Options. Now this is where we would use the rest roughing. Now rest roughing is going to take a look at the, in this case, because I'm doing it all in one window, it's looking at the previous operation, and it now knows that this part has already been cut by a 3/4 inch tool with a flat bottom, and it was leaving 15 thousandths. We're also leaving 15 thousandths. So really, this is just going to go into the areas where that 3/4 inch tool couldn't fit, and it's going to add the path into there for us. So other than that, really no changes for the rest of it. The rest of these settings are all the same as before. And now we get to our advanced Z level. So this one is going to use a 1/2 inch ball mill, but I'm going to change it to stick out 2.5 inches. And when I hit next here, we should get an error because the advanced planer and the pencil mill are using the original tool I had in here. But since I'm changing it, when I hit next, it's going to ask me, do you want to make those same changes to the other features that are using that exact tool? So I'll say yes, and there we have it. For the patterns, we'll go from the top down, but we could go from the bottom up. We'll go ahead and zig to keep everything moving in one direction, and we'll go ahead and go with a climb mill. Next again. Now for the depth of cut, I'm just going to set this to, we'll go 25 thousandths. I want a decent finish. So 25 thousandths is a good number to be at. But we do have some options for this. So there's machine flatlands. Now normally with the Z-level toolpaths, it doesn't matter if it's the standard Z-level rough, Z-level finish, or the pro advanced Z-level finish. These toolpaths are good at cutting walls. They like to cut steep walls. So the problem you run into is if your depth of cut doesn't naturally end at a floor, a lot of times you'll leave some extra material on the floor of your part. So the machine flatlands is going to ensure that you get at least one pass at the floor level, so it's easier to blend that floor into that wall. The machine vertical walls only is going to take out any walls that don't read as 90 degrees. And the adaptive depth of cut allows us to set up our initial depth of cut, so we're going to say 25 thousandths. But in the areas that need more, we could tell it it's allowed to go to 10 thousandths, and it'll add extra toolpath in as needed. And you could even have it trim step passes so it only cuts in the areas it needs to. Because if we look at the original form of this, we don't need any of those extra cuts on the backside. That's a straight wall all the way around. So this would allow us to trim them so we have just shorter passes. I'm going to leave that on for now. I don't think it'll do much for us, but we'll go ahead and hit next. Oh, we have our allowance here. That's set to 0 because this is a finished pass now. Right here for the leads, just going to plunge in. And with that plunge, we have a vertical, a parallel, a right angle, or a circular lead. I'm just going to go vertically. There's only 15 thousandths of material left for this thing to clean up. The options, you have your boundary options, which we don't have a boundary set up right now. So I'm going to go ahead and just tell it 3D extents. Pretty much if this option's available, I turn it on. It's a good place to start. Once in a while, I do have to switch to part bottom, but usually the 3D extents does a fine job. And then right here, we have our angle range. So this allows me to limit the output of the angle for this toolpath. Now, like I said, it likes cutting walls and it doesn't like cutting floors. So with this, I could tell it to cut, just like this picture shows, I'm going to go from 30 to 90. And it's only going to cut to that 30-degree mark or anything to, from 30 degrees to vertical. So we'll leave it there. Right here, we have our links. Just how do we connect from one pass to the next? We could go follow. We could go direct, horizontal, vertical, spiral, S-link, or a full retract. Right here, we have our gouge check. Again, I have no idea if I'm going to gouge, so I'm not going to assume that I am. So I'll go next. And for the advanced feeds, we can convert our rapids. We could change our lead in and lead out feed rate percentages, and we can actually affect the link feed rate. So then next, right here we have the advanced planer. So we're going to set up our 1/2 inch ball right there. Our patterns, we have a zigzag, a zig, or up and down cutting right here. So zigzag is going to go back and forth, and then we set up our lace angle. Now the lace angle is based on pretty much an arc. Just know that 90 degrees is always going to be parallel to the y-axis. 0 is always going to be parallel to the x-axis. So for this one, I'm going to go along the 90, and that's going to go back and forth this way in the part. Next again, I'm going to go with a step over on this one of just 25 thousandths, just like before. But again, this one does have the adaptive option. So we have a minimum step over. So it's if you were in areas where you wanted BobCAM to add a little bit of extra toolpath, the adaptive is the way to do it. You tell it the base step over and then the minimum step over, the smallest step over in between. And then right here we have perpendicular. So this one is actually going to ignore, in our case, it would ignore any cuts that are going to come out with a bad finish along the x-axis direction. And it's going to cut everything along the y, and then it's going to switch directions and cut along the x. So you end up with kind of a tool path that does a really good job in both directions. But we'll go with just the standard cut. We shouldn't need anything fancy because we're going to use angle ranges. We have our step over amount, tolerance, top and bottom of job. We have the allowance here. I'm just going to go next. Now for the leads, we can plunge, we can ramp, or we can spiral. So on that plunge, we can plunge in vertically. We can do a parallel lead, a right angle, a circular, or a vertical tangent. Right here for the options, I'm going to use the 3D extents because it's available. And then I'm going to set up my angle range. Now the angle range for this one, I could go from 0 to, I'll say 0 to 35. So we get a little bit of a 5-degree overlap between the two, the advanced Z level and the advanced planar. Right here for the links, what do I got for my pattern? I'm with zigzag. Okay, good. So for the links, we could either follow the surface, we could do a horizontal then vertical step, we could do a direct, a blended spline, and a full retract. Next, again, we have our gouge checking and our advanced feeds. Now, finally, for the pencil mill, we're going to set up a specific tool, and this is going to be a 3/8 ball. So I'm going to say 0.375. And then for the corner radius, the easiest way to get it is to do the diameter of the tool and divide it by 2. And that way it always gives you a ball mill of that. So we'll go next. Right here, we're just going to climb mill. There isn't a lot of options with this pencil mill because it's reading the model and figuring out where the tool can go. So there's no step over amount. We don't have to worry about a top or bottom of job or the allowance because we're finishing. We could do multiple passes, which allows us to cut around the fillet a little bit more. We shouldn't need that right now. For the leads, no changes there. We got plunge, we got that ramp, we got the spiral. This should really only be going in and cleaning up the corners of the parts. Right here for the options, no changes. We're not even doing angle ranges on this one. For the links, we'll go with follow, but we do have direct, S-link, or retract. And finally, gouge check, no changes, and the advanced feeds. When we're all done, we can hit finish. Now, the reason I hit finish instead of compute is just in case when I go to compute my toolpath, something happens. So before I go and compute this, I'm just going to go to File and then give it a save so that it saves all those toolpaths for me. And then I can right-click on that feature 3-axis and I'll say Compute All Toolpath. And we'll just wait for these guys to calculate. All right, now that it's finished calculating, I always like to blank everything out, so I'm just going to say blank unblank all, and I got to get a better color for this part. Hold on, let's go something darker maybe. Too dark. Let's go something a little lighter. Let's go over there. I don't want it to be too dark. That'll work. I can work with that. So when we look at this now, here's our advanced rough. So that's the first one going in with the 3/4 inch tool, doing everything it can. Nothing to complain about. Here's the 1/2 inch tool that's just going in and cleaning up the area that previous tool couldn't fit in. And then we have our advanced Z level going in and cutting any of the steep walls. We then have the advanced planer, and you'll see this one's cutting a lot more than it needs to. This top of part's already done. And then we have the pencil, just going in and cutting those radiuses in the corners. So first things first, let's edit this advanced planer. And the way that I'm going to tell it not to machine the exact top of part is by changing the top of job. And all I'm going to do is say minus 0.1. And that should be enough where it won't affect any of the tool path that's down here that's actually cleaning up the part, but it should get us to drop below the top of job there, the top of the part, so it doesn't see it. So I'll say finish, and then I'll just compute just that one because that's the only one that changed. We don't have to compute the rest of them. So we'll let that calculate. And there it is. So now I can go up to my simulation. Before we launch the simulation, though, we're just going to hit File, Save, and then we're going to go ahead and launch the simulation here. All right, now that the simulation's loaded up, first I'm going to turn off the workpiece here. I'll hide that. And then we're going to slow this down. And so this is the 3/4 inch tool going in, and it's just going to start cutting everything that it can. Now, I don't want to go too fast because I want to catch the intermediate steps that happen along this, but they shouldn't be happening until the end. So it's going to rough everything out. And then right here, we'll start to see them. So we got these big steps in the part. And this is going to go back and recut those steps as it works its way through. So something like that all the way around. Right there, and that's where it's breaking it into the smaller steps. And we only went with 2 intermediate steps. If we went with 3 or 4, we'd have even smaller steps for the finished tools to have to work into. So there we go. And now we start with our 1/2 inch, so it's just going in. Really, the rest roughing, that's really going to be used to go tighten up corners. And like we see here, it's getting into a slot area where that previous tool just couldn't fit. So it's going to clean up that. We'll see it clean up some of these other corners as well. And then we're going to switch to our ball mill here in a second for the advanced Z level. So now we're getting to the point of finishing this part. And if we think about this, if we had done this a little bit differently, instead of using a 1/2 inch ball, it might have been better to use that 3/8 ball the entire time. And we might not actually have had to use the pencil mill, but we'll rough it out. You know, this 1/2 inch tool can take a bit more than the 3/8 slightly. Some of them are about the same. And so we'll see it's just working down to the point where it's at about 30 degrees. So it's cleaning up what it can. And then we are going to come back and refinish some of these other areas that have steep walls, like right in here, right down there. And then we're going to switch to our planer tool when we get to about here. So we've had a collision. Now what this means, and what we'll see is it's a tool flute and a stock collision. So the flutes hit the stock. For me, that's not a big deal, But basically what BobCAD's seeing is that the tool might have clipped a piece of material it wasn't expecting. So that could be a problem. I don't know what it would be caused by. Maybe we have to go set leads on some of these moves or leads inside that Z-level finish. But for now, I'll say, yes, I do want to continue. And we'll see it's just going to run. So it could have been clipping something in here that the planer is going to clean up, and that's unexpected for a collision there. And that's why that thing might have happened. So we'll let that almost done. Now we're onto our planer. And so the planer is just going back and forth across there. Back and forth in there. And you'll see the excess material that we have down in there. And that'll hopefully be cleaned up unless we didn't set enough allowance. That'll hopefully all be cleaned up when we run the pencil mill. So we'll find out here in a second. Or we have to change the allowance that's left on the part. There we go. There's the planer. And then the pencil mill is going to run very quickly. So I don't want to miss it. We should be right close to that. There's this. Come on. There we go. There's our pencil. So we're going to focus on this one right here, or really any of them that we can see. I need to add leads to that. But there it is right there. And so we'll see. Right there's the unexpected lead. So I do have to add leads onto the pencil mill for it not to read these gouges. So I'll say, yes, let's continue. There it is. And there it is. And you can see it cleaned up the base of that. And so, again, the only change we'd have to make would be that right there. And on something like that for the pencil, if it's especially going with that vertical kind of movement there, we could see right now it's kind of rapiding into this. I can actually edit this feature. I'll go to the pencil leads option, and I'll tell it to use a parallel lead. And I'll use a 1/4 inch. That's fine. So we'll say finish. And then we'll go ahead and come on, compute that. And so where it needs that extra lead, it will have that extra lead now. Or we could go with a circular or whatever, right angle lead. We can go, let's see, a right angle lead and then say finish and then compute that path again. And so there it is. So it's leading in, feeding up, and then cutting. Looks good. That one wouldn't be any good, actually. Let's go with, we'll go with the parallel for that one. So leads, parallel, finish, and then I can recompute that one. Now remember, when you're doing this, if you hit compute, you're gonna have to sit through it recalculating all those tool paths. So try and hit finish and only recompute the one that needs it. So now that that part's done, once again, we would first check out the machining order, which at this point is going in the exact order I have my cam tree. There is no other way to do it this one, unless we reorganize the entire tree or this feature, which you can do just by grabbing and dragging and switching the positions of tool paths. The next thing we would look at would be the tool assignment, if we need to change any of the tool numbers in there, which I'm fine with those ones. And then we would make sure we have the right post processor and machine. And then we're ready to post. So we could post our code. Code's going to show up right under the posting tab. And there it is. Again, if you do not see arc moves in the code, that shows up on the posting tab right here. So if I turn this off and I just say finish, it's an option where we don't have to recalculate anything. If I go and post my code now, we'll be able to see it's all line moves. And if we go all the way down to the bottom, we're at 32,354 lines of code. So 32,000, let's just remember that number. If I go back in here and I set this back to posting and I turn that back on, I say finish, and then I post. We'll go from 32,000 down to 8,700, so 8,700. So that cut it down quite a bit. Did a really good job for us there. And that's it. There we go. So that was a 2-axis part earlier, and we just did a 3-axis part here now. And I didn't make a whole bunch of parts. So if you guys have any questions, feel free to add them in. Like I said, this is going to be, I'm just going to do the first half of the day today. And I'm going to come up with a plan on what we're going to do for the next time around. And next time we'll probably focus specifically more on 2-axis. And then another day we'll do specifically 3-axis. So if you have any questions, feel free to throw them into the questions box and I will try and answer those questions for you. or if not, get you an answer. And yeah, you have a good day if you're not going to ask any questions. Thanks, guys.